All right, so this is a 0.04 kilogram ball attached to the end of a horizontal cord rotated in a circle of radius 1.6 meters on a frictionless horizontal surface. If the cord will break when the tension exceeds 56 newtons, what is the maximum speed the ball can have? So let's start with a picture. Okay, so we've got this mass, this ball, and it's rotating around and around the circle. So it's looking like this motion, but remember that it's always moving tangent to the circle. So imagine that velocity is like shooting into the page there. It's kind of hard to draw 3 dimensions in a 2-dimensional space. So the question is, what's the maximum speed the ball can have? Well, in this case, a free body diagram of the ball would give us a force tension towards the center. There would be a weight on it because it's on the earth. Now it says it's a frictional surface, so we don't have to worry about anything scrubbing it around, but it'll have a force normal up. Now remember, this normal force here and this weight force here will be equal because it's in equilibrium. So I would draw them to be equal lengths. So this tension force is what's pointing towards the center. So then our tension force, when I sum the forces in the x direction, you can go ahead and think of this as being like an x-axis, and this as being a y-axis. So the sum of the forces in the x direction would be equal to, well, it's unbalanced, so there would be a tension force, and an unbalanced force would be equal to ma. Now let's look at the overall picture. So this ball is moving around and around a circle, so there's a center over here. So this is a special acceleration, not just any old acceleration. It's a centripetal acceleration. And so I'm looking for the maximum speed. What is the maximum speed the ball can have? So I know that this centripetal acceleration is v squared divided by r. So I'm going to use what I've been given in the problem and solve for that v. So let's put in the maximum tension that was given, which was 56 newtons, is equal to the 0.4 kilogram ball times v squared is unknown, and then the radius we were given is 1.6. So then we do a little algebra and multiply by 1.6 on both sides, divide by 0.4 on both sides, and then 224 is v squared, so take the square root of both sides. And we get a tangential velocity of 14.97 meters per second squared, about 15 meters per second. This is not squared, just meters per second. Okay, so we started with this problem where we had the mass attached to a horizontal cord rotated in a circle. We had the radius, frictionless horizontal surface. The cord will break if this tension gets over 56, so that was my maximum to put in. And we're looking for the maximum speed. I drew a picture of the situation where we had our velocity tangent to the circle. We had the object moving in a circle. Then I drew a free body diagram just to remind us that we have forces that are pointing towards the center. We have a force that is up from the surface. We have a force that's down because of the gravitational force. Then we can substitute in and find our velocity because I'm looking for the velocity, the maximum speed, but it's buried inside the centripetal acceleration function. So we have to take care of this guy right here. So then doing the algebra, we get that the velocity is about 15 meters per second.